software lifecycle model, and we have discussed few steps of classical waterfall model and what is classical waterfall model. Okay, that is, we have discussed requirement analysis and specification, requirement gathering and analysis, and we have designed also the design part, and it is of two types, that is traditional design approach and object oriented design approach we have discussed. And the next part is coding. Okay, so implementation of the project. So how do we implement a project? So the purpose of implementation phase is coding and unit testing phase. So actually it is used to translate software design into source code. Okay, so why do we use coding and unit testing phase? Basically, the purpose of the coding and unit testing phase of software development is to translate the software design into source code. So the coding phase is also sometimes called the implementation phase, since the design is implemented into a workable solution in this phase. So each component of the design is implemented as a program module. The end product of this phase is a set of program modules that have been individually tested. So to enable the engineers or to write good quality programs, every software development organization normally formulates its own coding standards that suits itself. So a coding standard address issues that such as the standard ways of laying out the program codes, the template for laying out the function and module headers, commenting guidelines, variable and function naming conventions, and the maximum number of source lines permitted in each module. Okay. So during the implementation phase, each module of the design is coded, each module is unit tested also. So tested independently as a standalone unit and debug, and each module is documented. So after coding is complete, each module is tested. Unit testing involves testing each module in isolation from other modules. So if I take a real life example of testing, if I am taking Viva, suppose I am taking Viva, or suppose if I have given you CA1, okay. So all of you are doing CA1, so instead of giving the assignment of CA1, if I could have given, I could have conducted a Viva, okay. That means I am taking Viva of the students one by one. That is, I am isolating one student from the batch and I am asking him or her questions. So that is a part, that is, if I am considering the set of students as a whole system, then I am dividing a particular student from that system and I am testing that particular student by taking Viva. So that is called, I am taking the whole, from the whole system, I am taking just a unit of that system, that is the unit can be considered as a student. That unit I am testing, or I am taking Viva to check whether that person is properly following the lectures or it is so this is the concept of unit testing. So unit testing involves testing each module in isolation from other modules, then debugging and documenting it. So the main objective of unit testing is to determine the correct working of the individual modules through unit testing. So during unit testing, each module is tested isolation as is the most efficient way of errors identified at this stage. So I take, if I start asking questions to all the team, then what will happen? I won't be able to analyze whether everyone is following my lectures or everyone is doing their studies properly or not. Because whenever I will be asking one question, everyone will raise the hand and it will be difficult for me to evaluate figuratively. But instead, if I am taking unique entities like unique persons or one person, one after another, and I started taking Viva, then it will be easier for me to understand that this student is lacking to this particular section. This student is very good. The student's performance is very satisfactory. The student is very good and is not doing his studies properly. In this way, I can Understand? Okay. So another reason behind testing a module in isolation is that the modules with which a module under unit test needs to interface may not be ready. So unit testing holds a precise definition of the test cases, testing criteria, and management of testing. Next, this is about unit testing. Next, integration and system testing. So, what is integration and system testing? Integration is, as in the in class 12, you have done different, you have done maths. In maths, you have done integration, differentiation. So, what is the meaning of integration, students? Anyone having any idea? You have done integration in class 12, right? 10, 12 in calculus, you have done integration, differentiation. Hello, students, are you there? Please respond. So basically, integration means summing up, okay? Summation. Whenever we have done integration, that means we have integrated, that is, we have summed up all the modules. So integration of different modules is undertaken once they have been coded and unit tested. So during the integration and system testing phase, the different modules are integrated in a planned manner. The modules making up a software product are almost never integrated in one shot. So integration of various modules are normally carried out incrementally over a number of steps. During each integration step, previously planned modules are added to the partially integrated state and the resultant system is tested. Finally, after all the modules have been successfully integrated and tested, system testing is carried out. So the goal of system testing is to ensure that the developed system conforms to its requirements laid out in the software requirement specification document. So system testing usually consists of three types of testing activities. So, So this is the after all the modules have been tested successfully integrated and tested. So system testing is carried out. So goal of system testing is to ensure that the developed system functions according to its requirements as specified in the SRS. System testing is of three types. One is alpha testing. System testing is of three types. Okay. One is alpha testing. Another one is beta testing, and the third one is acceptance testing. Acceptance testing. Okay. So, what is alpha testing? Alpha testing is the system testing performed by the development team. Okay. So, whenever you are developing any software and you are doing the testing by your own, then that is called alpha testing. Okay. Next one is beta testing. What is beta testing? This is the system testing performed by a friendly set of customers. That is, you after completing the project, if you are given that project to some friendly set of customers or in your own company who use that project and who analyze that whatever errors are there in your project, then that is called beta testing. Okay. And the third one is acceptance testing. So what is acceptance testing? This is the system testing performed by the customer himself after the product delivery to determine whether to accept the delivered product or to reject it. That means whenever the client is coming to your company and demanding some requests to make a software. Okay, so you have completed the software and you have done the testing. You have checked that there is no error in your software by yourself. Then you gave the software to a friendly set of customer. Okay, whatever you have done, that is alpha testing. Then you are giving that software to a friendly set of customers you are again rechecking your software whether it is correct or not. Then that becomes beta testing. After that, you are delivering that software to the customers or the client who has demanded that software, and after that the client is checking that whether that software is working correctly or not. That means whether he will accept or reject the software. So that kind of testing is called acceptance testing, in which the client is checking the software whether it should be accepted or rejected. So system testing is normally carried out in a planned manner according to a system test plan document. The system test plan identifies all testing related activities that must be performed and specifies the schedule of testing and allocates resources. So it also lists all the test cases and the expected outputs for each test case. So immediately after the requirement specification phase, a system plan can be prepared, which documents the plan for system testing. So it is possible to prepare the system test plan just after the requirement specification, since it can be prepared solely based on the SRS. So the results of integration and system testing are documented in the form of a test report, and the test report basically summarizes the outcome of all the testing that were carried out during this particular phase. Next topic is, this is all about system testing. Next is maintenance. Okay. This is a very important part. As we have seen, this requires the most effort, because maintenance after development, after testing, it is a part of developing the software. And next part is maintaining that software. Okay? So how can you maintain a particular software? The maintenance of any software product requires much more effort than the effort to develop the product itself, and also development team to maintain maintenance effort is typically 40:60. So this is the project ratio in which it is divided. When if you are having a project, then 40% is taking for development and 60% is taking for maintenance. Okay. So see here, this is the effort. Okay. 40% effort is for development and 60% is for effort. So see, 60%, that is maintenance, is much more required. So maintenance of a typical software product requires much more effort than the effort necessary to develop the product itself. So many studies carried out in the past confirm this and indicate that the relative effort of development of a typical software product to its maintenance effort is roughly in the ratio of 40:60, as I said. So that is, the proportion of effort on maintenance can be higher for long-lasting software such as operating systems, certain product manufacturing software, etc. So on the other hand, the proportion of maintenance efforts can be low for software that are used for just a couple of years, such as software development for a certain business application, and the business itself gets absent. So maintenance involves performing any one or more of the following three kinds of activities. So see, it is consisting of three kinds of activities. One is corrective maintenance, another one is perfective maintenance, and the third one is adaptive maintenance. So what is corrective maintenance? So this type of maintenance involves correcting errors that were not discovered during the product development phases. So that is corrective maintenance, means you are correcting all the errors. The name you can understand by the name, that is you are correcting the errors whenever you are during the development phase, whenever you are seeing that there is some error in your software, so you are correcting that error in that phase is called corrective maintenance. Next comes perfecting maintenance. So you are doing the perfection, you are taking the software into perfection level. So that is called perfective maintenance. So this type of maintenance involves improving the implementation of the system and enhancing the functionalities of the software according to the customer requirements. Okay? So this is about perfective maintenance, means improving the software to make it perfect, like the one the client has demanded. Next is adaptive maintenance. So adaptive maintenance is usually required for porting the software to work in a new environment. Like whenever suppose porting may be required to get the software to work on a new computer platform or with a new operating system. Suppose you have developed the software in Windows, okay? So that software is should be comfortable because client has demanded that software. You want a software that will run in every operating system, okay? So suppose you have developed a software for Windows operating system, okay? So now you want to use Mac operating system or Linux operating system. Let us suppose you want to use Linux operating system, and suppose have seen that uh, while testing the software, we have seen that there is no error in your software whenever that is running in your Windows platform, Windows environment. But whenever you are transferring that particular software, Linux operating system, you have seen that it is facing some errors. It is hanging or it is showing some bugs or errors. That's why that is not acceptable as the client has demanded that it should be compatible in any environment, whether it is in Windows or Linux or any other operating system, it should be comfortable. So that's why adaptive maintenance is required to check whether that part of the software is compatible to a new environment or not. Okay, so there are many shortcomings. Next model is iterative waterfall model. But why do we need what iterative waterfall model? Now classical waterfall model is completed. Classical waterfall model is completed now. Next type of software lifecycle model is iterative waterfall model. So why do we use iterative waterfall model, and what are the shortcomings or disadvantages of classical waterfall model? So let's just understand and then we will move on to the next waterfall model, that is iterative waterfall model. So the classical waterfall model is a very simple model. As we have seen, it is very simple. However, it suffers from several shortcomings. Okay, so the classical waterfall model considers the transition between two phases to be similar to a waterfall. Okay, so you have seen a waterfall. Okay, just like the structure of the waterfall. So this that is, one phase is complete. The various activities during that phase are assumed to be flawlessly done, and there is no scope of rework for later time. Now see, you are saying that in the first phase feasibility study is done, and after this phase requirement analysis should be done. But if something happens that after feasibility study in the requirement analysis phase, or suppose in the design phase, that is the third phase, you are facing that feasibility study is not done properly, then you cannot move to the first stage because it is following sequence of stages like this. First step is completed, then second step, then third step. Okay, so when in the third step, if you see any problem, you cannot backtrack in the first step. So that is a disadvantage. Okay, you cannot, there was no scope to rework for the first phase. So that's why, suppose this is the third phase, if you are in the next case, in another case, suppose you are in the maintenance phase and you have seen that feasibility study is not done properly. So you need to backtrack and you need to go in the first phase. So that is, if you see that there is not, the first phase is not done properly, then if you see that it is, you cannot backtrack, then that is a problem. Okay, so that's why this is a very big disadvantage in classical waterfall model. Okay, so however, in practical environments, the developers do commit a large number of errors in almost every phase of the life cycle. So whenever you will develop a software in IT company, whenever you will get placed, you will see that in every phase, not every phase is perfect. Okay. In every phase, you will see that every developer is doing some error. Suppose you are some set of people is doing feasibility study, some another some in a team there are many members, like team A is doing feasibility study, team B is doing requirement analysis, team C is doing design. But if you see that in team A has not done, and it will happen that in team A the work is not done perfectly. So that's why the cause for defects can be many, like oversight or wrong assumptions, use of inappropriate technology, communication gap between the project engineers, etc. So these defects usually get detected much later in the life cycle. So that's why there can be many kinds of defects. So for example, a design defect might go unnoticed till the coding or testing phase is done. So once a defect is detected, the engineers need to go back to the phase where the defect had occurred and redo some of the work done during that phase, and also the work of later phases affected by the rework. So therefore, in any practical software development work, it is not possible to strictly follow the classical waterfall model. So that's why in real life or in most of the cases, what classical waterfall model is not followed. It is the most conventional model, and it was used. It was the first model that was developed. So this model also assumes that all the requirements are defined correctly at the beginning of the project, and on basis of that the development work starts. So however, that is the customer keep on changing the requirements as their development proceeds. Thus it becomes difficult to accommodate later changes required requests made by the customer. So as you know that our demanding is dynamic, that is it keeps on changing time to time. Whenever we demand something, after some days we demand something more. Okay, so that's why customer requirements also is not static, it is dynamic in nature, and it keeps on changing from time to time. So that's why if suppose after doing all the phases and you are in the maintenance phase, and suppose customer is demanding some other design, then also you cannot go back, because in classical waterfall model there was no scope of rework. So that's why that is also a disadvantage. You need to again do the same design and you need to change, so that requires a lot of effort. So also this model assumes that all the phases are sequential. So see here, this is actually following a sequence. So however, this is that is rarely the case. For example, for efficient utilization of manpower in a company, the members assigned the testing work may start their work immediately after the requirement specification to design the system test cases. Therefore, we can say that the design and testing phases overlap. So consequently, it is safe to say that in a practical software development scenario, the design different phases might overlap rather than having a precise point in time at which one phase stops and the other starts. So these are the disadvantages of classical waterfall model, for which we use another type of model, that is iterative waterfall model. Next time, iterative waterfall model. So we have seen, so classical waterfall model is idealistic and shows that no defect is introduced during any phase during any development activity. So in practice, defects do get introduced in every phase of the life cycle. So as we have seen that in practical software development work, it is not possible to strictly follow the classical waterfall model. So that's why we branded the classical waterfall model as an idealistic model. And in this context, we can view the iterative waterfall model as making necessary changes to the classical waterfall model so that it becomes applicable to practical software development projects. So The main change to the classical waterfall model is in the form of providing feedback paths from every phase to its preceding phases. Okay? So if you see, this iterative waterfall model, in this model, the difference between this model and the classical waterfall model is, see here, again it is following a sequence of steps and it is in the form of waterfall. But here, see, there is a this big difference. That is, in every step there is a feedback system. Okay, so whenever in feasibility study, if you face any difficulty, or in suppose after doing feasibility study requirement analysis in the design phase, if you see that there is some defects in feasibility study, you can directly go back to feasibility study. Whereas it was not present in waterfall model. In classical waterfall model, you need to again reconstruct the model. Whereas in this case, you can without doing any changes, you can directly move to the feasibility study section. Okay? So the main change to the classical waterfall model is in the form of providing feedback paths from every phase to its preceding phases. Okay? So the feedback paths, so these are basically feedback paths, and the feedback paths allow for correction of the errors committed during a phase and when these are detected in the later phase. So for example, if during testing a design phase design error is identified, then the feedback path allows the design to be reworked and the changes to be reflected in the design documents. However, if there is no feedback path to the feasibility stage, that means that the feasibility study cannot be corrected. Okay? So this is about iterative waterfall model. Uh, Iterative waterfall model also, all the phases are present. That is, we have discussed feasibility study, what is feasibility study, then requirement analysis, design, coding, testing, and maintenance. All the phases are same. So I'm not going to explain this, but what are the but here that though errors are inevitable in every phase of development, it is desirable to detect these errors in the same phase in which they occur. So this can reduce the effort required for correcting bugs. So for example, if a design problem is detected in the design phase itself, this problem can be taken care of much more easily than if the error is identified at the end of the integration and system testing phase. So it would be necessary not only to rework the design but also to appropriately redo the coding and the system testing, incurring higher costs. So it may not always be possible to detect all errors in the same phase in which they occur. The errors should be detected as early as possible. The principle of detecting errors as close to their points of introduction as possible is known as the phase containment of errors. Okay, so phase containment of errors is an important software engineering principle. So how can phase containment of errors be achieved? So there is an important technique that is frequently used in this regard to conduct reviews after every milestone. So that's why we have introduced a feedback system here. Okay, so in spite of best effort to detect errors in the system in which they are committed, still some errors can escape detection and would be detected in a later phase. So this necessitates reward of the already completed phases. Thus, a phase may not end at the specific time instant if we include the rework required to the phase later due to errors of that phase detected at the later phases. So basically, if there is it's like in our college also, whenever we are developing, suppose we are really teaching you, okay? So suppose I'm taking classes, I am giving lectures, and I am thinking that I am doing a very good work, whereas you are thinking that math is not that much efficient and also we cannot understand our classes. So that's why there is a communication gap between you and me. You are thinking something different and I am also thinking something different. And from my point of view, I'm thinking that I am working fine, whereas you are thinking that ma'am's class is not satisfactory. So in that case, that's why college has introduced a system that is feedback system. So in feedback system, you are giving feedback to every teachers, and after getting the feedback, we get to know that whether our performance is satisfactory or good or bad. Okay? So similarly, in every software, if you are giving feedback system in every phases, then we can understand that that phase, but that the whole software uh, is not incorrect. Only a particular phase is incorrect. Okay? So that's why we need this feedback system. Similarly, suppose in our college there are many faculties, and if I'm not taking classes properly, then based on my performance, no one, anyone, if anyone judges that this college is not good because all the faculties are bad. So that's why for my negligence, everyone is suffering. So that is not acceptable. So for that, feedback system has been introduced so that particular feedback of the particular teacher can be taken, and for everyone can understand that not all the teachers are bad. Only particularly this teacher is not performing well. So they can take measures for that particular uh, problem. So in this way, it is done. So this is about iterative waterfall model. So as I said, errors should be detected in the same phase in which they are introduced. For example, if a design problem is detected, if a design problem is detected in the design phase itself, the problem can be taken care of much more easily than say if it is identified at the end of the implementation and system. So this is about phase containment of errors. As I said, reason that is rework must be carried out not only to design but also to code and test phases. The principle of detecting errors as close to its point of introduction as possible is known as phase containment of errors. So iterative waterfall model is by far the most widely used model. So that's why in this iterative model we are learning the concept of phase containment of errors. So almost every other model is derived from the waterfall model. Okay. So classical waterfall model, irrespective of the life cycle model actually followed, the documents should reflect the classical waterfall model of development. So comprehension of the documents is essential. Metaphor of the mathematical theorem proving a mathematician presents a proof as a single chain of deductions. Okay. So even though the proof might have come from a convoluted set of partial atoms, blind arrays, and a classical waterfall model and iterative waterfall model. So there are also some shortcomings or some disadvantages in iterative waterfall model. For that, I have developed another waterfall model, that is prototyping model. You see in the first, it was classical waterfall model. In classical waterfall model, there was certain disadvantages, and that's why iterative waterfall model came. But here we also see that no model is perfect. Iterative waterfall model is also having certain shortcomings. So that's why another type of model, that is prototyping model, has been developed. So a good understanding of the waterfall model is necessary to appreciate and understand other development processes. However, the waterfall model suffers from many shortfalls. These shortcomings are addressed to different extent by the other life cycle model that we shall discuss. Okay, so the waterfall model cannot satisfactorily handle the different types of risks that a real-life software project may suffer from. This is the most important thing. It cannot handle the real-life risks. Okay. So, for example, if you take the waterfall model, assume that the requirements are completely specified before the rest of the development activities can start. Therefore, it cannot accommodate the uncertainties concerning the requirements that exist at the beginning of most of the projects. So as a result, it cannot be satisfactorily used in projects where the customer is not clear about his requirements and can provide the rough requirements. So for whenever the customer is not so much clear and is not sure about it, so that's why we cannot use iterative waterfall model. And in general, if you see whenever you will be working in any software company, you see that in most of the cases, that is in 99% cases, you will see that the customers are not clear what they want. Okay? Whether there is a communication gap between the customer and the developers, whether the customer, whatever the customer says is not understandable by the developer, or it may happen that the customer is not or not does do not know what that particular customer requires. So for that to achieve better efficiency and higher productivity, most real life projects find it difficult to follow the rigid phase sequence prescribed by the waterfall model. So by the term a right phase sequence, we mean that a phase can start only after the previous phase is completed in all respects. A rigid adherence to the waterfall model would create blocking.
हेलो मैम, आवाज नहीं आता, माइक पास में रख के बोलिए।
अभी भी नहीं आ रहा है? हेलो,
अब आ रहा है, अब आ रहा है।
आज तो ना आने का कोई प्रॉब्लम नहीं, आज तो मैं 11 की क्लास दे रही हूँ।
मैम माइक पास में रखते तो ठीक आता है।
हाँ, माइक तो पास में ही है, एकदम सामने है। तो a rigid adherence to the waterfall model would create blocking states in the system. So that is, once a developer completes his work, he idles waiting for the phase to get over. Since the work required to be done in a phase is distributed among several team members, some members will complete their work earlier than other members. So the team members who completed their work early would not be able to their next activity and would have to idle for some team members to complete their work. So this would clearly say that there is a wastage of resources and wastages are rarely tolerated in real projects. For example, if you say that there is an engineer who works fast and completes the design part assigned to him early, he should not sit idle. So waiting for others to complete their designs. Instead, he should proceed to start the activities for the next day. So this situation gives rise to overlapping of phases. So that's why there are these are the certain disadvantages that iterative waterfall suffers. That means whenever you are working, like I am dividing a project into different teams. Okay, there suppose team 1. Okay, this is team 1. This is team 2. This is team 3. So these are the different teams. Team 1, team 2, team 3. So see here, suppose team 1 is completing his work and then he is handovering that work to team 2. Okay. So in this case, team 1 is sitting idle and is doing nothing. So that is not acceptable because you cannot take the team members idle. You need to give them complete work all the time, and they are actually wasting their resources as well as time, and time wastage is not allowed. Similarly, team 2 has completed his work and is handovering that thing to team 3. Okay, so team 3 is working. In that case, team 2 starts waiting and team 1 is already waiting. So team 1 has to wait for 2 phases and team 2 has to wait for 1 phases, and team 3 is also waiting for 2 phases. So there is waiting happening in every phase, and that is not acceptable. So you cannot take your team members to an ideal state. So that's why this is the major shortcoming, because it follows a sequence, and whenever the first sequence is done, second sequence executes, or third sequence executes, the first and second team members remains idle. So that is not acceptable in real life projects. So that's why this is a very big disadvantage in classical and iterative classical waterfall model. So that's why we have generated a type of waterfall model, that is prototyping model. So prototyping model I'm not going to discuss today. We will start prototyping model in the next class. So students, is it clear to everyone whatever I said? Is it clear?
Yes, ma'am.
Okay. So already CA1 assignment is given to all of you. Start solving the assignment and you need to submit, as I said, you need to submit the assignment at the deadline is 22. So you need to submit it within 22 and the question is already given in TCS and you need to solve the question and you, submit it in the Google Drive which is provided by Shuman. Okay. So start doing it and I hope yes.
ম্যাম টিসিএস আইনে অ্যাড করে দিন।
আচ্ছা কে বলছো ঋতু?
হ্যাঁ ম্যাম।
ঠিক আছে আমি আজকে করে দেবো। ঠিক আছে। Okay students, so that's all for today. So we will again meet in our next class, that is tomorrow. So I'm closing this session. Thank you students for attending today's class. Now you can move.